We're going to look at monomial factoring, cancellations, and then parallel lines. This is what monomial factoring is. What can we factor from both terms? If you look here, they both have a 4. So we can pull out a what? A 4. And they both have 1x. What did we not pull out here? A and x plus y. Does that make sense? That's a plus sign. Does that make sense? To check, what is 4x times ax? And what is 4x times y? Are these the same? So then this, unless we made a mistake both times, we did it correctly. Does that make sense? Okay. So here's another example. Is that better? Does someone want to go factor it on the board? Do you agree? Yeah. Instead of 4, it should be. Oh, you hit extend. No, don't keep hitting it. Every time you hit it, it makes it like get longer. Now, do you agree? Does that make sense? Any questions on these? All right, here's another one. Someone want to go do it on the board? Is there a lot of work to show for these? Okay. Do you agree? You would have to have the -1 so that whenever you factor it back together, you keep that term there. Does that make sense? Yeah, because there's a negative there. And even if it was a plus 2x, yeah, you'd still have to have a term there. Does that make sense? So even if you factor everything out of that term, you still have to put a 1. Any questions here? If, like, on a test or something, let's say you missed this term, I'd like circle it. Okay. for these. We want to cancel if we can. What you want to do, first off, can you factor anything from these two terms? What can you factor? If you pull out an x squared, what is left? Do you agree? Can we factor this? It's just x squared because it's just one term, right? We've got this x squared and this one. Since it was in both of these, we can cancel them out. And what are we left with? 6x. Does that make sense? See how that works? Hopefully you'll get to the point where you can go straight from here to there. Okay? If you look here, can I make this that? Cancel those. Why can't I do that? This one has an x squared. This one has an x squared. Does this one over here have an x squared? So can I do anything with it? Because they don't have anything in common. Yeah. Because this doesn't have anything in common with the other two. Yeah. It's like saying you can't make that 3 plus 1. It's like 5 halves. Does that make sense? It's the same concept. Even though these look the same, you can't just like cancel them or even just make it 3. Any other questions? Yeah, that would be the answer. You can't do anything. Do I have the same? Apparently I do. Whoops. Okay. We've dealt with similar triangles before, right? We can also use parallel lines. This little arrow on the two lines means that they are parallel. Okay? What they want you to do, anytime you have parallel lines, take the two lines and make them, like, draw them further. Just extend them. Does that make sense? So that you can see that there are two pairs of, or there's a pair of parallel lines and then two transversals. Okay? This angle and this angle. What do we know about them? If they're doing with parallel lines, they're congruent. Same thing with this angle and this angle. Does that make sense? And then this angle has to be the same. Like it's on both triangles. Does that make sense? Okay. Looking at this one, where are the two parallel lines? Yeah, BA and ED. So what do they want you to do? Just draw the lines further. Does that make sense? How is this angle? Which angle is it? Angle E. And what angle is this one congruent to? And then what do we know about these two angles? They're vertical, and so they are congruent. Does that make sense? So the two sets are still similar, it's just using different information. That's all it wants you to know about those. So see if you can factor these 3 terms. you agree? Do what? Right there. Now, do you agree? Any questions there? Right? Simplify this one if you can. If not, then you just have to leave it. M to the fifth, or 6m to the fifth plus m squared all over m. Will it simplify? Someone want to go write what it simplifies to? You can do the next one. Go ahead. Do you agree? Do you? Do it. You would factor out an m squared, right? And then these two would cancel, leaving you with just 6m cubed plus. Does that make sense? Any questions? Okay. You can just put it in the basket. Do you need a note to go to band? Are the triangles similar? How do you know? Bases are parallel. Do what? You know how to do normal similar triangles? It's the same thing. Just instead of showing the angles that are congruent, now the triangles just. Tomorrow you want to go write the proportions? What did he say? Okay. Okay. Do you agree? Yes. You add them together. Three plus four. That makes sense? So what would you get for y? Will that reduce? Say what? They are similar because they have parallel lines. Does that make sense? Like normally they'll tell you about the angles, like normally that's what they'll do, but you also know that they're similar because of the parallel lines. Does that make sense? And so if y equals 49 over 4, how would I find x? You agree? Does that make sense? Any questions? 15, is that 15 over 4? Any other questions? Okay. Looking at this one, are the triangles similar? How do you know? They have parallel lines, therefore their angles are all congruent, so they're you treat them the same way as we did. To what? Which angle is congruent to this angle? Which angle is congruent to this angle? Down here. These are congruent. They didn't just take it and do this. Okay. So which angle would be congruent to that angle? The one up top. Does that answer your question? Someone want to go write the proportions? Do you agree? What did you get? So you always want to put 3 for an M on the top. Does that make sense? Any other questions on proportions? Okay. What would you get for N? Do you agree? What would you get for M? You agree with that? Any questions on these?